Okay students, in the last class we have discussed about many examples about the first order kinetics. Okay, now we shall take the other examples also based on the first order kinetics. Now one of the example like this, show that the time required to complete 99% of a reaction is twice the time required to complete 90% of a reaction. You understand the question carefully, even it is very important. It will be asked long answer question in PUC level, even it may be in the competitive exams also it can be asked. So you should know about what this numerical. So first of all, how to just get the relation. Even sometime it can be asked like this also. Show that, show that time required to complete 99% of reaction is twice the time required to complete 90% of a reaction. Like this also the question will be asking. So what we have to do is, in the beginning, first of all, we'll go through the solution. Okay, we'll go through the solution. Now you write what is it according to the first order kinetics. T 99% is equal to, what is it, 2.303 divided by K into log of A divided by A minus X. This is the formula we know in the case of first order kinetics. We know that what is it, A is equal to initial concentration only, it is 100% we have to take, okay, no? 100. And what is it, X is equal to, that is 99% of the reaction is completed, means you have to take X is equal to 99. Then what is it, A minus X? A minus X is equal to 100 minus 99, this is equal to 1 only. Now you substitute the value here, okay. T 99% is equal to 2.303 divided by K into log of 100 divided by 1, log 100 by 1, okay now? Okay. Now you tell me T 99% is equal to 2.303 divided by K into, what is this, log 100. Can you tell me what is that value of log 100? Log 100 is equal to 2.0. There will be 3 digits. What is the characteristics? Characteristics will be 2 only. Then the 10 and 0 if you see, then you are getting what of that, 0 only. So now the value of T 99% is equal to 2.33 by K into 2 we can write. This is what just I am telling you, the equation number 1. Similarly, you write now the equation number 2 for 90% completion of the reaction. How it is? You write like this only. T 90% is equal to 2.303 divided by K into log of A divided by A minus X. You know what is it? A is equal to, as it is 100 only. X is equal to what? That is 90% only. Then what is it? A minus X is equal to, that is 100 minus 90, this is equal to 10 only. So now you can write 100 divided by 10, okay now? Now 10 ones are 10 tens you can take. You write one more step here. T 90% of the reaction is equal to 2.303 divided by K into log 10. You should know the value, that is what no? Log 10 is equal to how much it is? 1.0 we are getting. Characteristics for log 10 will be equal to 1 only. 10 and 0 if you go, then it will be 0 only. So now what I am telling, the equation number 2 I write. That is T 90% is equal to 2.303 by K into log 10. Log 10 value will be equal to 1.0. This is equation number 2. Okay. Now you take, what is it? Compare equation 1 and 2 we can take. Compare equation 1 and 2. Or equation 1 divided by 2 we can write. What is that equation 1? Can you tell me now? Equation number 1 will be like this. That is T 99%, okay, divided by T 90% is equal to, what is it? You write that equation number 1, 2.303, okay, 2.303 divided by K into, what is it, no? The 2 only we can write, whole divided by S, that is 2.303 divided by K into 1 we can take. So now here now 2.03 by K and 2.03 by K get cancelled only. and finally what you can write, T 99% is equal to, or T 99% by T 90% is equal to 2, or finally what we can write, T 99% of the reaction is equal to 2 into T 90%. So this is what the final form we can write. Show that the time required to complete 99% of reaction is twice, means that is 2 times only the time required to complete 90% of the reaction. So this is one of the important one. Remember properly, and it is for long answer question also in PUC level. You have to simplify like this only. It is very important one. Following all of you. Nothing, just you go through the concept. What is the T 99% and what is the T 90%? That is according to first order kinetics. You should know the equation number 1 and equation number 2. Divide equation 1 by equation 2. Then accordingly you get that T 99% by T 90% is equal to 2, or it may be T 90%, 99% is equal to 2 into T 90%. This is what show that T 99% of the reaction is equal to 2 into T 90% of the reaction. Okay. Okay, this is another type examples regarding rate of reaction. You see first one, the temperature coefficient of reaction is 2. The temperature coefficient of reaction is 2. If the temperature of the reaction increases from 30 degrees Celsius to 80 degrees Celsius, how many times rate of reaction increases? We already know the things regarding what now, that temperature of the reaction, or what is the effect of temperature on the rate of reaction. What is meaning of this one sentence? The temperature coefficient of reaction is 2 means what? Temperature coefficient of reaction is 2 means the rate of reaction doubles, or it may be triples for every 10 degrees Celsius or 10 Kelvin temperature increases. For every rise in 10 degree or 10 Kelvin temperature increases means the rate of reaction doubles only. That is the meaning of the temperature coefficient of reaction is 2. Then how many times rate of reaction increases? Rate of reaction increases by how many times, 2 to the power n times it is. 2 to the power n times rate of reaction increases. Then what is it n here? We should know that n is equal to, what is it? Final temperature. Can you tell me? Final temperature minus initial temperature, okay na? Initial temperature whole divided by 10 we can take. What is it final temperature? Can you tell me? Final temperature is how much? That is 80 degree Celsius minus 30 degree Celsius initial temperature divided by 10, or this is equal to 50 divided by 10, or this is equal to 5 only. Is it not? What is it? Value of n, n is equal to 5. Following all of you. N is equal to 5 means 2 to the power of 5 only we can take. 2 to the power 5 times. The rate of reaction increases by 2 to the power 5 times, or this is equal to, so 2 into 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32 times the rate of reaction increases. We can take like this also. It is also one of the numerical that is based on the rate of reaction and temperature. So whenever it may be, temperature coefficient of reaction is given, means temperature coefficient of reaction is 2 means rate of reaction doubles for every rise in 10 degrees Celsius temperature. That is what now. In this final temperature and initial temperature, I have to take difference, that is how much now? 50. So total difference is 50 degrees Celsius. How many 10 degrees Celsius are there in 50? So I have to take 50 by 10. Will you get now? Value of n is equal to 5. Means how many times rate of reaction increases? 2 to the power 5 times. 2 to the power 5 times means that is 32 times rate of reaction increases only. Following? Similarly, we can solve this one also in the same manner. What is that second one? The second numerical you take. The temperature coefficient of reaction is 2. You have to note all the numericals, That is what temperature coefficient of reaction is 2. If the temperature of reaction increases from that is 50 degrees Celsius to 90 degree. how many times rate of reaction increases? You should know the point first of all. The temperature coefficient of reaction is 2 only. Then it is how many times rate of reaction increases by 2 to the power n times, we know that, okay. Then what is the value of n is equal to? N is equal to final temperature is 90 minus initial is 50 all divided by 10. Or n is equal to how much? 40 by 10, okay na? Or n is equal to how much? That is 4 only. Then 2 to the power 4 times the rate of reaction increases. Or you can take 2 into 2 into 2 into 2. Or this is equal to how much? 2 to the 4, 4 to the 8, 8 to the 16. The 16 times rate of reaction increases. In this we can solve some numericals that is based on temperature coefficient of reaction. If the temperature coefficient of reaction is given, that is 2 times means 2 to the power n time we have to take. If temperature coefficient of reaction is 3 given means no, that's what 3 to the power n we can take. Here coefficient of reaction usually 2, is it not? So 2 to the power n means how many times rate increase, we have to find the value of n. N if you get now, later you can take this one, that is 2 to the power n times, that is 2 to the power 4 times only. Then finally the rate of reaction increases by 16 times when temperature of reaction increases from 50 degree to 90 degree Celsius. You know that the reaction is carried out at what now? 50 degree Celsius only. The same reaction is carried out at 90 degree Celsius temperature, you know. Temperature increase means rate of reaction also increases. How many times increased? For every rise in 10 degree Celsius, rate of reaction doubles. That is a 2 to the power n times. Value of n will be like this. Then finally, these many times the rate of reaction increases. This is what you should know in case of what now? Rate of reaction and temperature coefficient of the reaction. Okay, this is what one of the important numerical based on the Arrhenius equation it is. It is not based on the first order. It is based on the Arrhenius equation. Following. Based on the Arrhenius equation at 2 temperatures. Here one temperature is given and here another temperature is given. Here one rate constant is given and here another rate constant is given. Based on the rate constant and the temperatures, we can use the formula to calculate what activation energy of the reaction. So now can you tell me how to solve this one? How to solve this question numerical? So we know that the formula accordingly log of K2 divided by K1, log K2 by K1 is equal to what, you know, log K2 by K1 is equal to EA divided by 2.303 into R, okay na? Into bracket to write that is T2 minus T1 divided by T1 into T2. So this is the formula regarding Arrhenius equation at 2 temperatures. Following. Now how to take the value of T1? What is the value of T1? So value of T1 is equal to, that is lower temperature. Among the 2 temperatures, the temperature will be, that is what the lower temperature will be, that is T1 it is. Is it not? That is 25 degree Celsius is the value of T1. So with respect to T1, we have to take what, that is K1 and K2. Is it not? With respect to T1, lower temperature, lower rate constant value, higher temperature, higher rate constant value. Because as the temperature increases, the rate constant also increases. You should remember the point. Rate constant vary with the temperature. Increase in the temperature, rate constant of reaction also increases. Therefore, now we know the value of T1. T1 is equal to 25 degrees Celsius. Is it not? At T1, what is the rate constant? Rate constant of a chemical reaction is 2.4 into 10 to the power minus 4 at 25 degrees Celsius. So you can write here now that value of the K1 also. What is that value of K1? So value of K1 is equal to what? That is 2.4 into 10 to the power minus 4 per second. 10 to the power minus 4 per second. Is it not? We should know the unit regarding rate constant also. Here the values will be like this. And we have to convert always degree Celsius into the Kelvin scale. Why? We just know the conversion. Degree Celsius plus 273 will get what on that Kelvin scale. That is 25 plus 273 will get 298 Kelvin is the value of T1. Then what is the value of T2? Higher temperature is what? That is T2 only. What is the air temperature? That is 40 degrees Celsius. 40 degrees Celsius plus 273 is equal to how much, 313 Kelvin. Similarly, what is the value of K2, K2? At 40 degrees Celsius, what is the trade constant? That is 1.0 into 10 to the power minus 3, 10 to the power minus 3 per second. 10 to the power minus 3 per second. And here, the value of the R, that is capital R, gas constant, 8.314 joules per Kelvin per mole. This is the value of what, that is rate constant. Value of what, that is gas constant, capital R only. Okay, now here, I substitute the values here. Just to make some alteration here. In order to cancel the values, just I am changing this one. Instead of 1.0, I take 10 into 10 to the power minus 4 I write, that is per second. So both are same only, okay, no? In order to get simplification, I just make easy for the calculation. Now you substitute the values here in this. What is it? K2? K2 will be 10 log 10 into 10 to the power minus 4, okay, divided by, what is it? K1 value. What is the value of K1? K1 will be 2.4 into 10 to the power minus 4 only, okay. Now this is equal to EA. EA you write as it is because we have to find the activation energy of the reaction, okay. Now EA divided by, what is this, 2.303 into, what is the value of R? 8.314. It is joules per Kelvin per mole. Value of R in SI system, that is in joules per Kelvin per mole, in joules only. That is why we have to convert the temperature into that Kelvin scale always. Usually during calculation, we take what in Kelvin scale only, that is for temperature values. Here also we convert degree Celsius into Kelvin scale. Now, what is the value of T2? Yes, T2 will be how much? That is 313 minus T1 value is 298 Kelvin, whole divided by, that is T1 into T2. What is the value of T1 into T2? That is 298 into 313. So like this we can just substitute the values first of all. Now you can simplify 10 power minus 4 and 10 power minus 4, that will be cancelled. And now here it will be what? Log 2.41 ja 2.416 we are getting, that is 4.16 only, is equal to EA divided by 2.303 into 8.314, okay, into bracket 313 minus 298 we are getting the difference, that is 15 Kelvin only, into 298 as it is you take, into 313 you take as it is. We take one more step. What is the value of this log 4.16? Log 4.16 is equal to how much, characteristic will be 0 only. 0 point. You see that 41 under 6. 41 under 6. That is 6191 you are getting. 6191. Following? Now you substitute that value of log 4.16. 0.6191 is equal to EA divided by 2.303 into 8.314, okay, na? Into 15 divided by 298 into 313, okay. And finally you write one more step, that is what activation energy EA is equal to. Can you tell me now? Activation energy EA is equal to, yes, you simplify this again, 0.6191, okay, into 2.303, okay, into 8.314, okay, into, you take this one, 298 into 313. So whole divided by, you take that is 15. Following all of you? On simplification you get what now? This value 0.6191, that is what now, log 4.16 only. Then you write EA is equal to this one. So finally I am writing the answer for that activation energy EA is equal to, yes, on simplification you tell me the final answer now. The final answer will be like this: EA is equal to 737.1 into 10 to the power 2. This is joules per mole is the value of activation energy. Following all of you, this is what very very important. 4 marks questions will be asking in the PUC level. Even in the NEET or it may be in CET, JEE also this kind of the questions will be appearing. But there will be some simple calculations. Based on the simple calculation, this kind of the questions will be asking. You just complete the numerical carefully and you should know the data carefully. So applying the formula is very important. For writing formula 1 marks they are giving, okay no? For correct substitution they are giving 1 mark, okay no? Is it not? For correct answer also with correct unit they are giving 1 mark. So minimum 3 marks questions sometime, or it may be 4 mark questions it will be. So 3 to 4 mark, that is long answer question only. You just go through the numericals even based on the Arrhenius equation at 2 temperatures. This is what very very important. Following all of you. Now we shall move towards the another one numerical. What is that? Rate constant of a reaction doubles when the temperature increased from 27 degrees Celsius to 37 degrees Celsius. Calculate energy of activation. Here also the same thing only. You just go through the data. What is the value of T1? Lower temperature, that is 27 degrees Celsius only. You convert this into Kelvin scale, that is 273. Is equal to how much it is? 300 Kelvin only. 300 Kelvin. Then what is the value of T2? That is 37 degrees Celsius plus 273 if you take is equal to how much? It is 310 Kelvin. Following. And what is the value of K2 and K1? And here no, what the question given is rate constant of a reaction doubles. Rate constant of a reaction doubles means that is no K2 divided by K1, that will be equal to 2 by 1 it is. Is it not? At lower temperature 27 degrees Celsius, the rate constant K1 will be 1 only. Then the K2 will be how much? That is doubles only it is. When it is the temperature increased from 27 degrees Celsius to 37 degrees Celsius, the rate constant doubles. So we have to take the K2 by K1 is equal to 2 by 1, or simply we can take no 2 only. K2 by K1 is equal to 2 we can take, or 2 by 1 also we can take, both are same. Okay, now you take the values here and substitute the values in the given formula. What do you know about the Arrhenius equation at 2 temperatures? Can you tell me? Here no, what is it? Arrhenius equation at 2 different temperatures, that is log K2 divided by K1 is equal to 2.303 divided by, what is it? Sorry, EA divided by 2.303. EA divided by 2.303 into R, okay, into T2 minus T1 divided by T1 into T2. So this is the formula we have to use for the Arrhenius equation at 2 temperatures. Now we substitute the values. So log K2 by K1. Log K2 by K1 is equal to what you know? It is log 2 only. This is equal to what you know? EA divided by 2.303 into, what is the value of rate? This one, our gas constant 8.314 joules per Kelvin per mole only, okay, into bracket, right, T2 minus T1, that is no 310 minus 300 Kelvin, 310 Kelvin minus 300 Kelvin whole divided by 300 into 310 Kelvin. So now we can simplify this one. Log 2 value. What is the value of log 2? 0 point we take. Characteristics single digit, no, 0 only. So 2.0. Is it not? The single digit means the characteristic will be 0 only. What is the value of log 2? That is 20 under 0. You have to see logarithm. 20 under 0, if you see, no, it will become 3010 only. And total value of log 2 is how much? 0.3010. This is equal to EA divided by 2.303 into 8.314 into 310 minus 300, how much it is? 10 only, divided by 310 into 300, that will be equal to how much? So directly you can take 300 into 310 only, I take like this one. Following all of you? Okay. Now what is the value of EA? A is equal to, you can, so 0.3010, A is equal to 3010 into 2.303 into 8.314, okay, into you take this 300, into you take this again 310, okay, whole divided by what? That is 10 we have to take. Following all of you? You do the calculation like this only, is it not? A is equal to this one into this, into this, into this, and into this. Following, divided by, whole divided by 10 you are getting. Yes. What is the final answer? Can you tell me? EA is equal to how much it is? What is the value of EA? Now here now, on simplification, you just tell me the answer. 53.59 into 10 to the power 53.59 into 10 to the power 3 into 10 to the power 3, it is joules only. So this is what the value of activation energy of the reaction. Okay, like this I have to simplify the numerical based on that Arrhenius equation. It is very, very, very important. 3 marks questions, 4 marks questions will be asked in the PUC exam. Even in competitive exam also, if they are asking very simple calculations will be there. Based on that, you can get the answer like this. So this is about one example regarding rate constant. What is that? The Arrhenius equation at 2 temperatures. 2 rate constants will be given, 2 temperatures will be given, even R value that is known only. Like this you have to simplify. But one thing you will keep in mind that whenever the temperatures are given in degree Celsius, you just have to convert it into Kelvin scale. Okay? This is one more example regarding the Arrhenius equation at 2 temperatures. See the numerical. The energy of activation of reaction is 60 kilojoules per mole. If its rate constant at 310 Kelvin is 2 into 10 to the power minus 4 per second. Calculate the rate constant at 320 Kelvin. Can you tell me what do you have to find? Rate constant at 320 Kelvin. Rate constant at 320 Kelvin. Rate constant at 310 given and rate constant at 320 not given. So you have to find the K2. You have to find what that is K2. What is the value of T1? T1 is 310 Kelvin. It is given only in Kelvin scale. And what is the value of T2? That is 320 Kelvin given only. What is the value of K1? That K1 is 2 into 10 to the power minus 4 only. 2 into 10 to the power minus 4. And you have to find K2. And then what is that? No, R value is given. That is constant only. Okay. And activation energy, that is 60 kilojoules per mole. One thing you remember, what is the unit of the joules per Kelvin per mole is given. What is the unit of the activation energy? Kilojoules it is given. So you have to convert this into joule only. So now you take the value of activation energy is equal to 60 into 10 to the power 3. It is a value of kilo only. Then it will become joule per mole only. Now you substitute the values in the formula. Now can you tell me? Yes. What is that Arrhenius equation at 2 temperatures? Log K2 by K1, okay, is equal to EA divided by 2.303 or into what? That is T2 minus T1 whole divided by T1 into T2. This is the formula. Okay, substitute the values. Now we have to find now the value of K2. Is it not? Then log K2 divided by K1. What is the value of K1 given? That is 2 into 10 to the power minus 4 only we take. Following. This is equal to EA. EA is 60 into 10 to the power 3 only. Following all of you. Divided by 2.303, okay, into 8.314, okay, into T2 minus T1. What is that? 320 minus 310 whole divided by 310 into 320, okay. Now simplify this. So log K2 divided by 2 into 10 to the power minus 4 is equal to 60 into 10 to the power 3. Is it not? 60 into 10 to the power 3 divided by 2.303 into 8.314, okay, into 320 minus 10, that is 10 only, divided by 310 into 320. So what we have to do now? First of all, you just simplify this value. What you are getting? Log of K2 divided by 2 into 10 to the power minus 4 is equal to how much you are getting. Okay, you will just tell me what is that value you are getting here. 0 point something you are getting, that is 3158. On simplification of total this one, okay, what you get? 0.3158. Then you have to find the value of K2. So now we can just convert, that is what? K2 divided by 2 into 10 to the power minus 4, okay? 10 to the power minus 4 is equal to anti-log of this value. Anti-log of 0.3158. Okay, how to find the anti-log value? Can you tell me? You just go to that anti-logarithms in that logarithm book, 0.31 under 5 under 8 you see. So you are getting that value. So now here now K2 divided by 2 into 10 to the power minus 4. This is equal to, you know how much you are getting? 2.061 you are getting. Then finally, what is that value of K2? K2 is equal to 2.061 into 2 into 10 to the power minus 4. Can you tell me what is that final answer? K2 is equal to, simplify and tell me what is that final answer. So 4.12 into 10 to the power minus 4 per second. So this is the value of what that K2. In this we can simplify the value of K1, or it may be the K2 by means of what this method. What is this is called Arrhenius equation. Based on the Arrhenius equation, there are the different numericals. We will have to see the numericals like this only. Okay, remember the formula and remember the steps and how to simplify by knowing all the values. These are all very important regarding Arrhenius equation. Now can you tell me, based on this one graph, we can also calculate what energy of the activation by using what that slope of the straight line. We have already discussed about what that Arrhenius equation. That is what one of the equation, what is called log K is equal to, you know, log A minus A divided by 2.303 into RT. This is the relation given by what Arrhenius equation. In this equation, if you plot a graph like this, that is what log K along y-axis, 1 by T along x-axis if we take, so you get what the straight line with a negative slope in this manner, is it not? And this is called y-intercept, that is C is equal to what? Log A only you are getting, and remaining this slope of the straight line is equal to what, you know, minus EA divided by 2.303 into R you are getting. This is the formula we have to use. Following? Now just you can apply the formula, that is what slope of the straight line is equal to minus EA divided by 2.303 into R you can take. Following? Yes. Now can you tell me what is the value of activation energy? Calculate the energy of activation. The question will be asked. Here the energy of activation is asked. Slope is given. Yes, tell me now what is the value of this slope? It is minus 5841. Is it not? Slope of the straight line is equal to minus EA divided by 2.303 into 8.314. So minus and minus 8 cancelled only. And what is that energy of activation? EA is equal to 5841 into 2.303, okay, into 8.314. So finally, what you are getting the answer? Just I am telling you the answer. 111,838. 838.45. It is joules per mole only. It is joules per mole only. Or it can also be written as 1.11838 into 10 to the power 5 joules also we can write. So this is about one of the numerical that is based on the slope of the straight line. We can also find activation energy of the reaction. Just I am giving you one homework, you just do yourself only. Note down this one. The decomposition of compound A of compound A of compound A into product A into product. Okay, value of K is the value of K is given, it is 4.5 into 10 to the power minus 3. 4.5 into 10 to the power minus 3 per second at 100 degree Celsius. At 100 degree Celsius. Okay, and the activation energy of the reaction is the activation energy of the reaction is 60 kilojoules per mole. 60 kilojoules per mole. At what temperature? At what temperature would the rate constant be? Would the rate constant be 1.5 into 10 to the power 4. 1.5 into 10 to the power 4 per second. So you just have to solve this one. Now here the rate constant at 100 degree Celsius is given 1.5 into 10 to the power minus 3. That is lower rate constant only, it is higher rate constant only. This is what now the T2 you have to find. So value of T2, just I am giving you the answer. That value of T2 is equal to 297. This is what you have to find. 297. Okay, Kelvin. 297 Kelvin only reading the answer. Okay, you solve this one. T2 value. Okay.